Here's the Unit 6 practice test. So starting with concept A, I can solve equations. So in number 1, we're solving for x in all of these problems. So remember, first thing you have to undo is addition, subtraction. So I'm going to add 9 to both sides. So then I have 13x equals 43 plus 9 is going to be 52. And then we have to undo that multiplication. So then we're going to divide both sides by 13. So then I have x equals 4. All right, number 2, same thing. We have to undo addition, subtraction first. So I'm going to subtract 17. So then I have negative 8x is equal to negative 72. And then I'm going to divide both sides by negative 8. So we get x equals 9. Next problem, we have variables on both sides. So before we undo any addition or subtraction, we need to get the variables on one side. So I'm going to move the 4x over. So 6 minus 4 is 2. So I have 2x plus 5 equals negative 9. Now we can undo that addition. So I'm going to subtract 5. Negative 9 minus 5 is negative 14. And then lastly, we're going to divide by 2. So x is going to be negative 7. All right, and then this last problem. So there's a couple of different ways you can do it, but if we're talking order of operations, the first thing you should undo is that 3 on the outside that's being multiplied. So we're going to divide both sides by 3. So then we have 5x minus 8 equals 12. And then we're going to add 8. So 5x equals 20. And then divide by 5. So then we have x equals 4. All right, number 2, we're still solving equations, but now we're working with literal equations. However, the process should be the same. So in number 1, we're solving for a. So that means we need to get rid of the 12 and the m. So we're going to divide, since this is being multiplied, we're going to divide everything by 12m. So our answer is going to be 4 over 12m. All right, number 2, we're solving for a, so we need to get rid of the k and we need to get rid of the b. So this is read as a times k divided by b. So first thing we're going to do is we're going to multiply both sides by b. So then I have u times b equals a times k. And then to finish solving for a, we're going to divide both sides by k. So our final answer should be a equals ub over k. C, we're solving for x, so we need to get rid of both 2's. So first I'm going to add 2 to both sides. So I have u plus 2 equals 2x. And then we need to get rid of the 2, so I'm going to divide both sides by 2. So I have x equals u plus 2 over 2. Number 9. Letter D, we're solving for b, which is this very last term. So I need to get rid of the 9a and the negative 9. So I'm going to get rid of the 9 first by adding it. So I have z plus 9 is equal to 9a minus 3b. Now I'm going to subtract the 9a. So I have z plus 9 minus 9a is equal to negative 3b. And the last thing I'm going to do is I'm going to divide everything by negative 3. So my final answer is going to be what we have on the left-hand side, z plus 9 minus 9a over negative 3. All right, concept B is I can represent and solve inequalities in one variable. So for these ones, we are graphing these inequalities. So starting with number 1, it says x is less than or equal to negative 2. So I'm just going to put negative 2 on my number line. For this one, we are going to use a solid dot because of that line underneath here means that we are including negative 2 in our solutions. Since we're looking at less than or equal to, that means we are going to go to the left. Remember, one way you can check to make sure you did it right is the arrowhead should match the inequality symbol. I'm not going to put more numbers on the number line just because I think we get the point here. Number 2 says x is greater than -1. So again, we're going to put -1 on our number line. I'm going to use an open circle for this one since it's just greater than and it does not include -1, and greater than would be to the right. And again, a way that you can check is that your arrowhead should be going in the same direction as your inequality. All right, number 3 says Miss Tan is selling shirts for the math department. She needs to sell at least $360 worth of shirts to get a rate of $20. Miss Tan has already sold $160 worth of shirts. So remember, the way that we write our inequalities is the rate times x plus the starting point with your inequality is equal to your total. Okay, so I know my starting point is going to be 160 because that's how much she's already sold. Our rate, it tells us our rate here is going to be $20, so $20 per shirt. So that's going to be 20x plus 160. We know that's going to be equal to 360. And since it says at least, remember that at least is a greater than or equal to symbol. So there's the inequality to represent the number of t-shirts she needs to sell. So now we're going to solve it. So first thing I'm going to do is I'm going to subtract 160. So then I have 20x is equal to, greater than or equal to 200, and then divide by 20. So x is greater than or equal to 10. So I'm going to put 10 here. Since we are including 10 in our solution, I'm going to put a solid dot, and then we're looking for greater than or equal to, so I'm going to go directly to the right. All right, number 4, we are solving and graphing the inequalities. So remember, for our solving rules, they're relatively the same steps with one special thing we need to do. So first, I'm going to undo addition subtraction. So I have -2x is greater than or equal to 4. And now I'm going to divide by -2. So here's where the special step comes in. If you divide or multiply by a negative number, your inequality switches. So this is going to be x is less than or equal to -2. So I'm going to use a solid dot, and less than or equal to is to the left. All right, the second problem for number 4, we're going to solve. So I'm going to subtract 33. So we have -6 is greater than -2x, and then we're going to divide both sides by -2. So again, we divided by a negative, so we should flip our inequality, and -6 divided by -2 is just going to be +3. When we're graphing, we should rewrite it so x is on the left-hand side. So this is the same thing saying x is greater than 3. So you can read it backwards, x is greater than 3, and we can rewrite it where x is on the left-hand side. So now I'm going to put 3. We're going to use an open circle because we're not including 3, and that's going to be the area to the right. All right, the final concept, I can graph inequalities in 2 variables. So number 1 says we're going to graph the inequality. So this includes shading. So first we're going to graph our line. So we begin at -3 on our y-axis, which is going to be right here. And my slope is 4. So slope is 4 over 1. So that means we're going to rise 4 and we're going to run 1. So from there, we're going to go up 4, right 1, and we're going to continue that pattern off the graph. Now we need to figure out what type of line we're going to do. So in this particular line, we're going to use dashed because there's no line underneath, which means that we are not going to include any of the points on the line. And now we need to determine which side to shade. So to determine that, we're going to plug in 0, 0. So it's going to be 0 is greater than 4 times 0 minus 3. Well, 4 times 0 is 0, so this is just going to be -3, -3. So 0 is greater than -3. That is a true statement. So since this was our test point and that side was true, that means this entire side is true. And this entire side is false. So now we're going to shade the true side. And now part A says determine one solution and explain why it's a solution, either using the graph or showing evidence algebraically. Don't forget to shade. So we already showed that 0, 0 is, but I'm going to pick a different point. Let's say we'll pick, actually, let's not pick that point. We'll pick this point right here. So that point is 1, 5. So on the graph, we can say that 1, 5 is a solution because it's on the shaded side, or the true side. Okay, but to show algebraically, we can plug in that point. So we can plug in 5 for y, so it's going to be 5 is greater than 4 times 1 minus 3. So this would be 5 is greater than 4 minus 3. So 5 is greater than 1, and that's true. So that would be showing algebraically. Okay. Number 2 says which inequality is represented by the graph. Well, we know that the equations of the line are the same for all of them. So now we're just going to determine which inequality symbol to use. So number 1, I know I can eliminate this one because if it were that one, it would have to be a solid line. I'm going to say not this one because the line is dashed. Okay, so now we have to determine if it's greater than or less than. So one way we can do it is we can try picking a point and plugging it in. So we know that if we pick 0, 0, our statement should be true. So if I pick, I'm going to take A, y is greater than 1/2 x plus 3. If this is the correct equation, when I plug in 0, 0, we should get a true statement. So let's see, 1/2 is greater than, or 0 is greater than 1/2 times 0 plus 3. So that would be 0 is greater than 3. Well, that's false. So I know it can't be this one. So that means it would have to be this one. So let's just check with this one. 0 is less than 1/2 times 0 plus 3. So that's 0 is less than 3. That's true, which means that we would shade the bottom side. Okay, the other way you can kind of tell is that the shading is below the line. So shading below the line, which is less than, and line is dashed. So that's why this is the correct answer. So that would be our explanation.